Hi everyone, myself Bharati Kannan, Assistant Professor from the Department of CSE in Hindustan College of Engineering and Technology. So today we are going to see the topic which is of a shortest path algorithm from the subject which is called as a design and analysis of algorithm. So these are the outline of this shortest path. The other name is called as a Digistra's algorithm. So introduction of the topic, then step-by-step process, and one of the example of a graph to solve the Digistra's algorithm. So this is a general introduction of a data structure. So what is a data structure here? It's a way of organizing, storing and retrieving the data and finding the relationship with each other. Generally, we are dividing it into two types. One is of a primitive data structure and another one is of a non-primitive data structure. So integer, float, character, pointer, these are the primitive. Now we are going to see one important topic which belongs to the non-primitive data structure, which comes under the graph. So here it is a single source shortest path algorithm or Digistra's algorithm. So generally a graph which consists of set of vertices and edges. So 6, 4, 5, 1, 2, 3. These are the vertex in the given graph and the line connecting the vertex is called as a edges. So this is a simple example for a single source shortest path algorithm by means of a graph theory. So generally the graph is of two types. One is of a directed graph and another one is called as an undirected graph. If it is an arrow in the edges, it is called as a directed. If it is of a cyclic and as well as acyclic, then it is called as an undirected graph. So here we are following the greedy approach. So the input is of a weighted graph which consists of set of vertex and edges. So it is mentioned by the capital G equal to set of edges comma vertex. So the output is we are finding the shortest path from the origin vertex to all other vertex in the given graph. So it is an initial graph we have taken for an example which consists of 5 vertex named as A, B, C, D and E. So followed by the connection of lines between all the vertex in the given graph. Initially we are taking A as a origin vertex here, that is called as a source vertex. So the connection of edges is not established among A, so it is considered as a traveling distance of 0. So the other shortest path we cannot identify at the initial stage, so we are considering it as a infinity here. So A to B is of infinity, A to C is of an infinity, A to D is of an infinity and A to E is of an infinity. So the set of vertex is empty at an initial stage. So initialization we have taken source vertex A as a 0. So the connection establishment between B and C, so the weight among B and C is calculated. So if you look at the slide, then you can able to understand the connection establishment between B and C. So here we are establishing the connection between the nearest vertex which is of B and C, so 10 and 3. So the remaining vertices in the given graph is considered as a same infinite position. So after constructing finalizing the visiting vertex of a single origin vertex, we have to take the smallest value among the nearest vertex of the given graph. So here B and C are the nearest vertex of a source vertex. So the minimum weight is C. So the connection establishment between C from the origin vertex of A is calculated. So D and E are the direct connection establishment from C. So origin vertex is of a known value with lowest weight of 3. To reach the D is 8 plus 3, 11. So from A to E, it is of an A to C, then from C to E. So 3 plus 2 is of a 5. If you look at the next table, it will be of clear from A to C of a visited known vertices. So the weight of the C, E, D and B is calculated. So what is the minimum distance to reach these B, D, E through the vertex C from the origin vertex of A. So the known vertex is A and C. So eliminating these two from the visited part, we have to take into consideration of B, D and E with the lowest weight of 7, 11 and 5. Among 7, 11 and 5, which is the lowest value? From that, we have to visit the unvisited vertex in the given graph. So 5 is a lowest value. So E is considered as a next known vertex. From E, uh, distance is to be calculated with B and D. If it is low with the existing value of B and D, a replacement of value will be carried on. Otherwise, the existing will be kept as a lowest value to visit from the origin node. So E is an intermediate vertex. So from A, the value is calculated and E is considered as a visited node. So here the set of vertices A, C and E is visited. So now the value of B and D remains unchanged of 7 and 11. Among 7 and 11, which one is the lowest value of a vertex? So 7 is considered as a lowest value. So origin from origin vertex, we have to calculate the value here. Now 7 is considered as a visited one. Then the remaining one D is of a lowest minimum value and make it as a known vertex at last with a weighted value of 9. So from origin vertex, we have to visit all the vertex in a given graph with a minimum weightage. So A to B of lowest weight 7, from A to C with 3, and A to D with the lowest weight of 9, and A to V with the lowest weight of 5. Thank you.